So for example 3, we're going to be finding the domain and the range of this function from a graph. So it says find the domain and the range of the function represented by the graph. Let's see what we got. So for part A, we have, again, a bunch of separate points here. We have a coordinate down here at -2, -2. Another one at -1, 0. Another one at 1, 2. And then one final one at 3 and 4. And we have to remember the domain is really just a really fancy word. So I'm going to use another color actually. So domain is just a fancy word for collection of all x's present in my function. So I have to list all the x values, all the x part of the coordinates that come out here. So I know I have -3. I know I have -1. I know I have 1. And then I know I have 3. So these are the only x values present. And you know what? I'll even draw the coordinates here so that we can know where all these numbers are coming from. So here's all the coordinates. The domain is just the collection of all the x values. Fancy word for something really basic. And then we have the range, which is basically the same thing, but now we're dealing with the y coordinates. So we have to list all of the y coordinates that are present in this graph, in all of these points. And in this case, we're going to see that it's -2. And then we have a 0. And then we have 2. And then we have 4. And then normally these are going to be listed in order from least to greatest. So just get into the habit of doing that. But that's it. That's my domain for this function. That's my range for this function. The collection of all my x's, the collection of all my y's. So for part B, now we have something a little bit more, I don't want to say complicated, but it is a little bit more involved. It's something that's connected. It's something that's continuous. Let me see if I can get the zoom on this thing right. There you go. Kind of. Alright, so we have a graph. Everything's connected. And as we can see, this is a little bit more complicated than the last one. Now, we're going to have to list our domain and our range very specifically. In a very weird way, a very specific way. Let's see what I mean by that. So for my domain, I have to collect all of my x's. So if I have my x values over here that starts at -2, and then I track this graph and it goes over here, it keeps going, and then it goes all the way to the x value that's at 3. So in other words, we have to list all of the numbers between 1 and -1 and 3. All of those numbers become part of my domain. And now we can't even finish listing all of the numbers in between of them because we have all these fractions and decimals that are infinite. So instead of listing every number individually, we're going to use what we learned in our last chapter, which is this. We're going to say that my domain, the collection of all my x's present in this blue graph, is going to be all the numbers between -1 and 3 in inequality form. That's why we learned about these compound inequalities. So that's my domain, the collection of all my x's. And then my y, which is my range, is going to be something similar. We want to figure out what is the lowest y value that is present in the graph, and then what is the highest. So I can see that whatever this one is the lowest. It's right here. It looks like that's -1 here, down here. And then it goes all the way up to 2. Because this graph, it goes all the way up here, and I can connect this point to 2 right there. So now my range has to be this purple interval here, which is all the y values between -1 and a +2. And just like that, we listed all the numbers for my x and all the numbers for my y present in this blue graph.